These are called planetesimals. And then gravity starts to take over. Now you have enough mass where you can attract things not just by colliding with them and sticking together, but now gravity can go and pull them in. And gravity is an attractive force. And these things are like floating around. The gravity of each of them is attracting each to the other, and then they start to make bigger things, 10 to 100 kilometers across, the size of states. And when they get to, I mean, this process continues, and you get to things that are even larger, planetesimal size, and the process just continues. You make bigger and bigger things because what happens is the more gravity you have the more mass you accumulate into one thing, the more gravity you have. And therefore the sucking potential is bigger, and you start to accumulate more and more material, and that just accelerates the process because now you have a bigger thing with more mass. More mass means more gravity, and then you can really start pulling things in all around, and so on. So it's a runaway process. Once you start getting to things about 100 or 1,000 kilometers across, then they start to sweep up all the material around them in the protoplanetary disk. So imagine the early stage of the solar system was something like this. You had the dust initially, dust and gas, but those dust begins to accumulate into these rock-sized things, and they grow larger and larger and larger, and eventually make planets out of them. And imagine that this happened in the early solar system, which it did. In the early solar system, it looked something like this. So you had all the shrapnel flying around and bombarding whatever was, the large planets or moons that were around. Now the moon, because it doesn't have any erosion, preserves a record of what happened in the early solar system. Almost all the craters of the moon were formed about 3 billion years ago, between 4 and 3 billion years ago, and then it stopped. That's because in the early solar system you had all these planetesimals. They were hitting the moon like crazy, and eventually they all became incorporated into planets. And then they disappeared, they're gone. Some of them still survive. They're the meteors and the asteroids. So these are fossils of the early formation of the solar system. Now, does this process work elsewhere? Well, yeah, because we see planets everywhere. The technique that you use to find planets is just by looking for the Doppler shift. You're probably familiar with this. You're looking for motions induced by the planet moving around the star. And when the planet moves around the star, like gravity, and if it moves around the star, it tugs the star as it moves around. So when it's on this side, it will tug the star this way. When it's on this side, it will tug the star that way. Well, you can look at the motions of the stars by the Doppler shift of its spectral lines. And you can detect these periodic changes from moving away, moving toward, moving away. And that's how you find planets. We found 150 planets this year. There are 100 billion stars in our Milky Way, billions of planets. And there's the Earth, one of those perhaps trillion of planets in the Milky Way. So, star formation, planet formation, that's our story, that's our origin. Thank you very much. Yeah.
Question. In a certain region of one of those dark areas.
Just a minute.
Okay.
Pardon.